So problem 2E from Managing Finances says, for each $3 spent in food, $4 was spent in clothing, costs being equally distributed between shirts and pants. If $56 was spent in pants, how much was spent in food? So what we have here is two things, clothing and food. So we have food and clothes. And clothes also break into two, so shirts and pants. Let's first solve this problem using equations, and then let's draw a bar model to, just to compare both solutions. So first, using algebraic equations, so when I say for each $3 spent in food, $4 is spent in clothing, what I can say is first that I spent more in clothing and I expend actually 4/3 of food. So clothing, let's just say C for clothing, is 4/3 of food. Because for each $3 that I spent in food, I spent $4. So if I break food into 3 and then I multiply by 4, that exactly captures clothing, 4/3 of food. And now, and it makes sense, right? Because 4/3 is bigger than 1, so C will be bigger than F because I am applying a fraction multiplication, 4/3 of F to get to C. And now it says that costs of clothing are equally distributed between shirts and pants. So this means that both shirts and pants are 1/2 of clothing. So these are my three equations that relate my three variables. Now let's see what else. So I have $56 spent in pants, so I know exactly that P is 56. And with that I can find everything else, right? Because if pants is 56, then clothing should be twice that. So clothing has to be twice 56. So how do we duplicate 56? Well, we first duplicate 50, that's 100, and then we duplicate 6, that's 12, so 112. And also S, so shirts, should of course be 56 because it's also 1/2 of C. And I want to check how much was spent in food. And so now what I can do is rewrite the first equation as follows. Food is 3/4 using algebra properties of my clothing. And my clothing is 112, so what I really want to do is 3/4 of 112. How do I do that? Dividing by 4 is the same as dividing by 2 twice. So let's divide 112 by 2 twice. So 112 divide by 2. Well, we already saw it was 56. Then divide by 2 again. 50 divided by 2 is 25. 6 divided by 2 is 3. So I get 28. And then what I have to do is multiply that 28 by 3. And multiply by 3 is just, adding it 3 times. So 20, 20, 20, that's 60. And 8, 8, 8, that's 24. So that's 84. And that's the solution. That's the answer. I spent $48 in food. Now let's do the following. Let's compare with a visual approach. So bar model. So let's look at our visual method, in this case bar model, And let's draw a bar model. So how do I draw a ratio 3 to 4? I just draw a big bar and break it into 7 parts, because 3 plus 4 is 7. So I need those 7 equal parts to make sense of this ratio. And so you can either draw the bar yourself, or when your students draw it, just make sure it's, you know, the pieces look kind of the same. I mean, it doesn't have to be exact. And this is another concept, that when you draw in mathematics, okay, you're drawing something that tries to be perfect, but you're not perfect. So, I mean, you just have to tolerate that. As long as you have the concepts clear, it's totally fine. So 1, 2, 3, 4, 5, 6, 7. So these are 7 equal pieces. And so what I want is 3 of them given to food. So 3 is for food, and the rest is for the clothing. And that makes perfect sense, because for each $3 of food, I spend 4 in the clothing. So if I spend 3 of something in food, I spend 4 of something in clothing. And then clothing is divided into equal parts, because it says being equally distributed between shirts and pants. And fortunately, we've got an even number of of pieces, so this is even easier here. Otherwise, we would have to make another partition, but here is totally fine. Clothing is equally distributed between shirts, and pants. So that's our visual model. And look how this represents at the same time. I mean, in both, all 3 equations, they're there, right? In a single picture, you can see the 4/3, and you can see the 1/2 and the 1/2. So that's the advantage. It's more holistic, meaning that you see the whole thing in just one representation. 56 was spent in pants. So if I know that 56 was spent in pants, I have to do 28 and 28. There's no other way. But if this piece is 28, then every other piece is also 28, because that's when we do ratios. That's our convention. Of course, all these little pieces have the same weight, the same value. They represent the same quantity. And so now we just answer the question, how much was spent in food? It's just triplicating that 28. That's it. So food is 28, 28, 28. There you go. That's food, right? So the bar model just tells you the answer. You just have to know where to read it. So 28 times 3. As previously we did. I just realized this is 84. Sorry, in the beginning here, of course, 84. So sorry about that dyslexia. Not 48, but 84, right? 60 plus 24, and here we just prove it again. So 84, which is a nice thing about doing problems in both ways, that you can check your mistakes. So the final answer is 84. Now, what's important is that students realize what's the connection between equations and between the bar model. That they can see the equations in the model, and they could formulate equations from a model.